Hi friends, welcome to follow up. Let's have a look at problem 542, 01 matrix. This problem is today's daily challenge problem. And in this video, we are going to explain a solution based on multi-source breadth-first search. So here we are given an m by n binary matrix called mat. So we want to return the distance of the nearest zero for each cell. The distance between two adjoint cells is 1. So here, for example, we have two examples. In the first example, so there are 8 zeros. There's 1, 1. So this 1 to the nearest zero is 1, right? So the four directions are all having distance 1. So in example 2, so the middle one should corresponding to a distance 1 to the nearest zero. The two corner ones in the last row also correspond to distance 1. And well, the one in the middle of the last row has a distance 2, right? That is 1 to 1 in the last item in the output. So with that said, we can roughly look at the constraints. So the number of cells, that is m times n, is bounded above by 10 to the power 4. And there is at least 1 0 in the matrix. So with that said, basically we are ready to write the code. So here, because we want to consider nearby distance, nearest distance, so we can think of a breadth-first search, right? So this is very direct. So with that commented, let's look at the coding part. So this coding is rather straightforward. It basically corresponds to translate our thought into code format. First, let me get the length of the matrix and the length of a row in the matrix. So this m and n are corresponding to the number of rows and number of columns in the matrix. So next, we want to find the source. The source actually is the cells with element 0. So here we are going to use this. Because we are going to do breadth-first traversal, we're going to use a queue. So here I'm going to use the stack. So let's also find the source cells. So here I'm going to use list comprehension. So for ig, so meanwhile for these cells with value 0, its distance to the nearest 0 will be 0, right? So here for I in range m, for j in range n, and the condition is if mat ig equals 0, right? So that's the source part. So basically we have this source queue initialized. So next, basically we just do the traditional traversal. Let's use a set. Here I'm going to use a dictionary to monitor the process. So this one will store the cell and the nearest distance corresponding to a 0, right? So now let's do the while loop, while the source queue. So first let's get the information. So source pop left. That's why we use this deck, because it has a pop left method, which is typically faster than the pop 0 of the pure list. So now let's check if ig not invisited. What we want to do is we want to set visited this key, right? We can pass ig like this because this is a tuple, right? Or you can write like this mob formal, right? So let's keep this. You can choose either. So this will be the D, right? So now let's check the neighbors. So for RC in, let's use a set. So the four neighbors, I plus 1, J, and I, and J minus 1, I, and J plus 1, right? So we want to make sure this position RC is inbound, not visited, and corresponds to a value 1, right? So here, if this R is less than M and C less than N and C not in visited, and matrix at this position is 1. If this is the case, so we're going to append this information. So here the information should be RC because it's a neighbor, so we're going to write D plus 1, right? And then this finishes the traversal, and it will gather all the necessary information in the visited site. So next, let's prepare the return. So for the return, let's initialize a m by n table. And then we just need to iterate, right? So for I in range m, for j in range n, right? So what we want to check is, so if this k is in visited, right? And what we want to do is we set the result ij equals visited ig, right? And then what we want to do is to return the result state. So this forms a full solution format to this problem. Before we make any comments, let's first do a test. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the generic cases. So here, let's quickly overview the structure. So here, what we used is the so-called multi-source breadth first search. So in this format of solution, we first get number of rows, number of columns, just for convenience. And then we initialize the queue. So because we want to do breadth first search, so the corresponding data structure is queue. So here we are using the deck object because this deck has a method called pop left. So this will accelerate a little bit. So when we do the initialization, we used list comprehension, right? So this line of code initializes the source or the queue. And then we initialized a variable called visited. So this is a dictionary which plays the role of recording the cell and the nearest distance to a 0. And then we do the while loop. For the while loop, we first get the information in the queue, and then we check if it's not visited, we add the information to the fetch, and then we check the for neighbors to see if they are inbound and not visited and corresponds to a cell with value 1. Then we equal this piece of information. So here, because we consider the neighbor of ig, so the distance should be d plus 1. In other words, incremented by 1. And after this, this is the bulk of the work. And then we prepare the return. So for prepare the return, you can use a for loop like this, or you can just use list comprehension. So with that said, basically that's about it for this video. Thank you.